Well, my talk is in the context of the previous roundtable. Here, it is a brief outlook to the quantum technology market, to the market value, to the segmentation of market, to the market geography. This work was initiated last year in partnership with Rostelecom, and with it was supported by Innopratica. It is a non-governmental development institution. And the outline of my talk is the following. First, we have a quick look on the quantum technology market as in general. Then we consider the market geography, its segmentation, and take a closer look on the sub-technologies of the quantum technology market, namely quantum computing, communications, and quantum sensing and metrology. Speaking about the methodology, the question which raised yesterday, we used the data from this report of Mind Commerce, the international consulting company, which is targeted on the technologies, on electronics and other technologies. Also, we took into account these publications by other consulting agencies and other publications, for example, from Nature, and some publications about the state policy and strategy. I have to say, before I start, that as the results presented here are based on the statistics, and as you have heard from the previous section, from the roundtable, the statistics is very small. It is just a few companies, and there are just hundreds to thousands of purchases of the devices, of the equipment. So this statistics is probably not very representative, but it can show the direction of the development of the quantum technologies market. Okay, quantum technology market at a glance. First, I would like to start from the decomposition of the market of the quantum technologies to the three quantum technologies being in the heart of the second quantum revolution. There are quantum computing, quantum communications, and quantum sensing and metrology. Here are the data, the numbers which characterize the evolution, the estimated evolution of the quantum technologies market, divided into these three technologies. So, as one can see, it starts from like around $2.3 to $2.4 billion in 2019, and it is expected to grow up to almost $15.5 billion until 2025. Who will be on this market? We take a look on the composition into small and medium businesses and large enterprises, and it is estimated that the large enterprises is occupying now the most part, the largest part of the market, and it will remain on the first place up to 2025, it will occupy 3/4 of the market. However, small and medium businesses are expected to grow. Not really much, but it will have a place on the market. Where the money should come from? There are three probable sources: government funding and investments, enterprise investments, and consumer purchases. I think that this estimated picture is really expected, that the government support is around a quarter of the whole market, while the big enterprises are funding 3/4 of the market for now, and their role will remain as the first role, the main role, until 2025. The consumer purchases are really neglectable in 2018, but it should grow 5 times, but it will remain less than 5% of the market.
What do you mean by enterprise funded? Is this investment?
Yes, there are investments, there are buying of the equipment for these projects, so on.
I am surprised by this number. I would think the government or general institutional funding is much larger than that. So, where did you get the numbers from?
Yes, the numbers are mostly from here, from this report. This report was done by that company. They took a big research, statistical and economical. They collected a lot of data. They spoke with experts, with companies, and so they collected and analyzed the data at
And it's supposed to be the current status or
the current state.
This one, yes. Is it current or is it expected? Or is it a market? It's a potential market?
This state was in 2018, and it will evolve into this state.
I think explanation might be that, for example, if you take the US market, a lot of the companies like Google, IBM, if you take a look at the US market, a lot of the companies like Google, IBM and others are funding their quantum research, specifically the quantum computing. So that maybe explains why 74%, as I understand, is considered price funded.
Yes, of course, and the decomposition into the states and the geographic distribution will be shown next. So here it is. Okay, in Nature, last year, the paper appeared which shows the geography. Unfortunately, the world map here is not really visible, but it shows the geography of the investments into the quantum technologies, and it attracted the scientific attention to this question. So we presented further the data which are segmented into these regions: North America, Europe, Asia, Pacific, and Australia, Latin America, Middle East, and Africa. North America occupies almost half of the quantum technologies market. Europe and Asia are sharing second and third places. And well, probably would exchange between these second and third places in the nearest 5 years. In North America, USA occupies 3/4 of the market, and it will remain on this place up to 2025. While Canada was just 17%, and its share will decrease down to 14 as estimated. In absolute values, in USA, the market grows from about $1 billion in 2019, and it is estimated to grow up to almost $5 billion in 2025. Behind this growth, there are some governmental initiatives which leads to the popularity of quantum technologies in USA, and actually it's spread around the world. The most of these initiatives are military. For example, Air Force Research Laboratory established quantum communication laboratory and aims to quantum key distribution and data encryption. Air Force Office of Scientific Research is into quantum sensing, computation, and communications. Well-known DARPA has 3 programs in quantum communications, quantum sensing, and less known IARPA, which is connected to the US intelligence, has programs directed to quantum algorithms and hardware to solve some optimizational problems. Los Alamos National Laboratory is aimed at quantum computing and quantum cryptography. The Quantum Artificial Intelligence Laboratory is studying quantum computers now. Also, National Science Foundation of USA has some programs, actually 2 primary programs directed to quantum information science. Office of Naval Research has a program for quantum key distribution and for quantum computing algorithms, and so on. Canada is also known in the quantum technologies, probably at first for the D-Wave company, and the estimated market volume for Canada is, it starts from $200 million in 2019, and it is estimated as around $1 billion in 2025. It also has some state initiatives, some governmental initiatives in investment of institutes and university. Also, it collaborates with USA. For example, Virginia Polytechnic Institute and D-Wave formed a quantum computing center for the US intelligence and Department of Defense to solve problems which stated by these agencies.
And not a premier, probably the perimeter institute.
Oh, sorry, probably it will be a mistake. Thank you. Also, there are collaborations between the companies which are aimed for the development of quantum technologies in Canada. For example, BIT and D-Wave Systems started an initiative called Quantum for Quants, which is aimed to introduce the quantum computing into the finance sector and to solve the problems of the finance sector using the quantum computing. as well CEO of D-Wave Systems and with the co-founder of BlackBerry. Together established the Quantum Valley Investment Fund, which has a size of funding around $75 million. In Europe, we have the following situation. At 2019, the first 4 places are occupied by Germany, UK, France, and Russia. Germany is a part of the European Union, is governed, for example, by the Quantum Flagship program, which is well known. Also, there are some national programs in Europe. For example, UK, which market is estimated as $170 million in 2019 and estimated to grow to $0.75 billion in 2025. It also has national programs which are aimed to transfer quantum research to the industry. Probably I have to be a bit faster. Also, not only the governmental programs in UK and other countries, and the example of the partnership with the companies, there are quantum research laboratories in Toshiba Corporation and Hitachi, which are placed also in UK. Russia occupies for now the 4th place in Europe in this estimation, and its market is estimated is like $80 million in 2019, and it is expected to grow up to $450 million in 2025. The initiatives in Russia are probably well known here. Probably the first initiative was the creation of the Russian Quantum Center in 2010. Then the Kazan Quantum Center was established in 2014. 2 national technology initiative centers were established in 2017 and 2018. One is placed in Moscow State University, which I belong to, and the another one is placed in BCS. And in 2019, 3 corporations made commitments to Russian government to develop these 3 quantum technologies: quantum computing, quantum communications, and quantum sensing and metrology. Rosatom, RGD, and Rostech. Also, besides the government initiatives, there are probably a few vendors which are going to present products on market. Big one is Infotex, for example. A smaller is Curate, for example. But well, before their products will be presented in market, they should be certified, which was discussed on the round table before. Also, I have to name Switzerland in context of Europe because ID Quantique is a well-known company, and so Switzerland has its governmental initiatives Also, specifically in quantum science, in the Swiss National Science Foundation. Speaking about Asia Pacific region, the first and second places are took by Japan and China respectively, and probably their positions will remain for the 5 years. In Japan there are a lot of initiatives, specifically with their Toshiba Corporation, which is involved in quantum technologies. In China, there are a lot of governmental initiatives, and first of all, quantum communications are named as one of 6 major science and technology development projects in China. So the governmental support in China is very high. In the countries of ASEAN, the market growth would be from 90 million up to 760 million until 2025. There belongs Singapore with its initiatives. South Korea also plays a role in the quantum technology market. Here, South Korean telecom company plays a major role in initiatives. Also, there is an Australian initiatives. However, its market is not really big. In Middle East and Africa, I think these data are very raw, and they are. It is too early to start to discuss them. So, the quantum computing market. Who are on this market? I mean, how it is segmented. In geography distribution, there are the companies which are presented in the quantum computing market, quantum computing specifically, and here you can see that USA is presented by the largest number of the companies. Market of the quantum computing can be segmented as follows. And for this segmentation, there are hardware, surveys, and applications. So this segmentation is represented by this estimated dynamics. In the global market, the quantum computing market starts from $1.6 billion and is expected to grow up to $11 billion. And the main part of this market belongs to the hardware component. However, starting from 2022 or 2023, the application software component is expected to grow faster. Probably there would appear the algorithms or maybe hardware which can compute these algorithms, which should be applicable for the companies, the problems of the industry. The hardware can be decomposed into physical devices and programmed infrastructure for these devices, and the physical devices itself should occupy the main part of the market. The application segment can be also divided into the optimizing problems, simulation problems, and sampling. So, as one can see, simulation and optimization are considered as the most are expected to grow faster than the sampling problem. Speaking about the service component, it also can be divided into managed services and professional services. And the managed services will occupy the main part before, well, from the 2023, and then the comparable parts will be occupied both by managed and professional services. Professional services include installation and the maintenance of the hardware, while the managed services include, for example, computing services, cloud computing, and so on. And the professional services are expected to be divided as follows. Here one can see that the deployment and installation together with the infrastructure maintenance will occupy the most part of the market, while strategic consulting will be more or less significant in 2024, 2025, and the industries which are interested in quantum computing are presented here, and in this table there are numbers for each industry. However, one can see that healthcare and pharmaceutical, together with banking and finance, are the most prospective industries for quantum computing. They would occupy together like 40% of the market, and their share will remain up to 2025. So, quantum communications market. The companies are presented here. One can see that there are the distribution is more smooth there than for the quantum computing. There are more companies in Asia, in Japan, in China, in Europe. There are companies, and of course in USA there is more companies than in other countries. The market is segmented as follows. The core of segmentation is the hardware, cryptography, and services. And here again, hardware occupies the main part of the market during the whole period under consideration, while device-independent cryptography, which discussed on the round table for me, is considered to be significant already from 2021, and its role will grow up to 2025. Hardware can be decomposed into the servers, blades, research and development platforms, and a random number of generators. And here, server and blade solutions are also by the main part. But actually, random number generators are also have a significant part of the market. However, the market itself is estimated like $2 billion until 2025. The services are segmented into integration and deployment, support and maintenance, and professional consulting. And integration and deployment looks as the most prospective part of the market. Speaking about industries, telecommunications and IT, together with military and defense industry, are the main industries interested in quantum communications. So quantum sensing and metrology. There are also some companies in the world which are working in this direction. And the quantum sensing and metrology can be represented by the following perspective products. Where atomic clocks, gravity sensors, and magnetic sensors are considered as the most perspective from the point of view of money. However, besides the sensors, there is also quantum imaging devices, including the sensors, which is also very perspective. One can see it in this diagram that quantum imaging devices occupies 23% of the market, while atomic clocks and magnetic sensors are less than 20%. Atomic clocks can be segmented into the technologies underlying these devices, and the estimation shows that the most prospective technologies are the cesium clocks, rubidium clocks, and also chip-scale atomic clocks, which are considered to be in demand. The light detectors, quantum light detectors, the most prospective single photon detectors, of course, and also photosynthetic sensors, which are highly demanded by the agriculture industry. Actually, that is why agriculture here is on the 4th place in the industrial list, while military and defense, together with automotive and transportation, which are occupying the first 2 places. So, in conclusion, I think I shouldn't read these conclusions because I already pronounced it, and I think that this presentation will be uploaded on the site of the conference, so anyone can read it anytime. Thank you for your attention, and if I have a minute, I would like to propose for discussion one question. Yesterday, Sergey presented the patent landscape. Today, I presented the estimation of the quantum technology market, and both of these research show a picture of the states, and it allows to compare the states in the context of quantum technologies. For another technologies, for example, for artificial intelligence, there are some ratings and indices which compare the countries where this technology is developed higher or lower. Probably the similar rating, similar comparison should be introduced in quantum technologies. In my opinion, this comparison should take into account research and development, industry and economics, and the role of quantum technologies in society. There are just a few of measurable coefficients which can be used to have an integrated index of a country to make rating. And so I would like to ask if such rating is needed and whether it should be well calculated. Thank you for your attention.
Okay, Sergey, thank you so much.
Yeah, thank you. Just a very short question. You showed an estimation. So, since we are in 2020, do you know if the first 2 points for each data, so 2018 and 2019, are in good agreement with the real data that we have now?
Thank you. This is a right question, and we are now working on it, and we are considering the possibility to refresh these estimations every year, and to probably make a model which can be used to prognose something. Thank you.
Sorry, the answer is not yet.
Yes.
Okay.
That's
Not
right.
yet. Okay, last question, please.
You speak about a market, but it's not really a market, it's investment by companies, so it's quite different, you know, that.
That's right, because there is actually no market at all. We do not have a certified products in quantum communications. We do not have, well, a general purpose quantum computer.
Despite that, people are paying. That is, for example, D-Wave, you can get their machine online, but you have to pay. It's the same thing for IBM now. So this creates some kind of small real market. So is it accounted for in the numbers? Or?
Yes, indeed. It have a small percent of these numbers.
It's a small percent of the 4%.
That's right.
Okay, let's thank Sergey again.